Let's talk about a parallelogram. This is a little bit different. We think of parallelograms, the main ones we think about is rectangles and squares, which is length times width. But what we can't do is length times quote-unquote width with a parallelogram. What we have to do is the base times the height. So we're actually not using the lengths of the sides. How do they get that? What they do is they take this, let me color in this little triangle right here. What they do is they take that triangle and they remove it, and they place that triangle on the other side right here. And once you remove it from the left side and put it on the right side, if you notice, what you have done is created a rectangle. And we know the formula for a rectangle is length times height. Well, the length of that would be the same. For instance, AD would be the length of it, but the height of it, notice, would be H in this case, which is the distance between A and E. It would not be that diagonal length. So cut off the end of it, make it into a rectangle, and do the length times the height. So it is not just the bottom times the diagonal side, it is the bottom times the height. So that's something that you might want to know for a parallelogram anytime they say it. It's the base times the height. Notice the height is not the slant distance in this one. Okay? Again, it's area, so we always have our units squared. Let's look at 13 then. It says a solar panel is the shape of a parallelogram that has a base of 2 feet and a height of 3 feet. Find the area of the solar panel. So we have our parallelogram. We have a base of 2 feet, and then we have the height right here is 3 feet. We know, so this is the base, this is the height. We know what we're trying to find the area of a parallelogram, so I'll just put A of par, and we know that that is the base times the height. Again, this is area, so it's going to be whatever our unit is, which is feet squared. So without doing any math, I've labeled the variables, I've written the formula, I've labeled my answer. Now let's do the math. The base was 2, the height was 3, 2 times 3 is 6. Again, that has to be our answer squared, or our unit squared, so that's going to be 6 square feet, or 6 feet squared. Example 14, let's see here. It says a fieldstone patio in the shape of a parallelogram that has a base measuring 14 meters and a height measuring 8 meters. What is the area of the patio? So again, this is a parallelogram. So we're thinking about a parallelogram here. There's a parallelogram. It has a base of 14 meters, and then it has a height of 8 meters. Okay, there's base, there's height. I've identified those. We're trying to find the area. So we're finding the area of a parallelogram, which we know is base times height. We know our units as meters, and because it's area, our answer has to be in meters squared. Again, we've labeled our variables, we've written our formula, we've labeled our answer. Now let's do the math. So the base was 14, the height was 8. Go ahead and put 14 times 8 into your calculator and let's see what you get. I'm getting 112. Again, that would be meters squared. Okay. There's a triangle. Again, you have a base and you have a height of a triangle. So how do you find the area of a triangle? Well, you do 1/2 times the base times the height. How did they get that? Well, we know that the area of a parallelogram is base times height, and all they did was double the triangle but flip it, put it together, and you'll see that all a triangle is half of a parallelogram. So if we know that a parallelogram is base times height, cut that thing in half and you have the triangle. So the triangle would be 1/2 base times height. So that's where that comes from right there. Sorry, let me highlight that. The area of a triangle is 1/2 times base times height. Again, a formula that you should either memorize or put on your note card if you're allowed one.